You know, usually when we think about typing our email address or phone number into a website, it feels entirely passive,
Right.
like dropping a letter in a physical mailbox. It's just
Well,
gone into the ether, you hit the sign up button, the little loading wheel spins for a fraction of a second, and suddenly you're in.
yep.
It feels like this totally clean one-way transaction. You give them a contact method, they give you access.
What creates an illusion of simplicity for you, the user. And that illusion is completely by design.
Right, they don't want you thinking about it.
Exactly. The interface is meant to feel quiet and frictionless. But the reality is that the moment you click that button, an incredibly complex, high-speed digital interrogation is triggered.
It's an absolute invisible battle raging behind the scenes. And, well, welcome to the deep dive, because today our mission is to take you right onto the front lines of that exact invisible battle.
We have some really interesting source material today.
We do. We're unpacking a fascinating stack of technical documentation and architectural overviews from a verification platform called ArkOwl. And we are going to explore exactly how businesses manage to separate legitimate, real users like you from a constant incoming tidal wave of sophisticated fraudsters.
Which is a massive problem.
Huge problem. Specifically, we're going to look at how ArkOwl pulls off this massive, real-time digital verification without completely compromising data security or user privacy in the process.
It's a critical mechanism to understand because the companies on the other side of that screen, they simply cannot afford to take your input at face value. I mean, a properly formatted email address means literally nothing to a modern security system.
Right, because anyone can format an email.
Exactly. To prevent fraud, to stop malicious actors from creating fake accounts, draining resources, or, executing massive scams, those companies require a profound amount of context.
They need to instantly know if the digital identity you just handed them possesses actual gravity.
Yes, digital gravity. And the core premise of ArkOwl's architecture is how they rapidly construct that context. They take that single piece of input, an email or a phone number, and they instantly aggregate over 81 different data points.
81.
Over 81, yeah, to build a comprehensive digital profile all in that tiny fraction of a second before your welcome page even finishes loading.
Okay, let's unpack this. Because pulling 81 distinct data points from a single isolated email address is just staggering.
It really is.
It's like someone handing you a printed business card at a networking event, and before you even blink, you've legally and instantly checked their entire social media footprint.
And their domain registration history.
Right, and cross-reference their public records, all while you're literally still reaching your hand out to shake theirs.
That is precisely the mechanism at play. We're moving light years beyond a simple syntax check. 10 years ago, a system might just ensure the email had an @ symbol and a .com at the end.
Which feels so ancient now.
It's entirely useless today. Fraudsters can automate the creation of millions of syntactically perfect email addresses in minutes. So ArkOwl's system ignores the syntax and instead dives deep into the broader digital ecosystem to see how that specific piece of contact info actually behaves in the wild.
Let's look at exactly what information they are extracting to make these split-second risk analysis decisions, because the architecture pulls from a remarkably wide net.
A very wide net.
They are pinging social media networks, checking with major webmail providers, digging into global domain databases, and scanning various open data sources.
And the underlying logic behind querying those specific, really disparate silos of information is what actually gives a defensive system its edge.
How so?
Well, consider that concept of digital gravity again. If you're a fraudster, you can generate a fake email address effortlessly. But can you retroactively generate a 5-year history of that specific email address interacting with new social media platforms?
Probably not.
Right. Or can you fake its registration history across multiple, completely unrelated webmail and e-commerce providers?
Yeah.
That is exponentially harder.
Yeah, that takes actual time and organic use.
Exactly. ArkOwl uses these diverse sources to look for a sprawling, organic digital footprint that essentially proves human authenticity.
Which brings us to the specific metrics they're automatically detecting. They are checking the email age, meaning the exact creation date.
Very important metric.
Yeah, and they're looking for real names attached to the account across different platforms, as well as any known aliases. They verify the registration status with popular service providers. Oh, and they also explicitly look for associations with known data breaches.
Which we should definitely touch on.
For sure. And I also want to mention the latest iteration of their system now includes real-time phone number verification to the this massive data set, matching the phone number's behavior across those same open sources.
It's a massive expansion of capability. But going back for a second, the inclusion of known data breaches is an incredibly revealing metric. It often seems totally counterintuitive to people outside of the cybersecurity space.
Right, because at first glance, seeing an email associated with a massive data breach sounds like a giant red flag.
You'd think so, yeah.
You would absolutely think that means the account is compromised and dangerous.
Exactly. But paradoxically, for a fraud analyst, seeing an email address show up in a massive credential leak from, say, 2018 actually acts as a bizarre certificate of authenticity.
Wait, really? A certificate of authenticity?
Yeah, because fraudsters do not typically use legacy compromised emails for mass signups. Those accounts usually have active real owners who will immediately notice anomalous activity or password changes.
Oh, that makes sense.
Right, fraudsters prefer freshly minted, completely sterile addresses. So a little bit of historical digital collateral damage essentially proves that the email existed years ago and belonged to a real human who was actively signing up for everyday services.
That is such a brilliant nuance. A brand new, squeaky clean email with absolutely zero history is actually far more suspicious than an email that got caught up in a gaming forum hack 6 years ago.
What's fascinating here is ArkOwl's absolute insistence on the real-time aspect of this data collection. The underlying mechanism of modern fraud prevention relies entirely on accuracy in the present millisecond.
The present millisecond.
Yes. They heavily contrast their architectural approach with competitors who pull from stale, potentially outdated, proprietary databases.
Well, if you were relying on a static database that was updated even just 30 days ago, you have a massive blind spot. An email that was perfectly safe and controlled by a legitimate user in January might have been hijacked and taken over by a malicious actor in February.
Precisely. If a fraud detection platform analyzes a user's risk profile based on a snapshot from the past, it's essentially flying blind. A sophisticated bad actor could be utilizing a newly created domain that literally went live 10 minutes ago, or a recently ported phone number.
Right.
If the system doesn't know about the status of that identifier right now, the entire security apparatus fails. By pulling 100% live, real-time data from these 81-plus sources, the system ensures that the decision is being made on the exact reality of that digital identity at the very second the user attempts to interact with the client's platform.
Okay, I have to push back on the mechanics of this, though.
Go for it.
If they are genuinely pinging 81 different live external sources for every single email address that comes through, how does that not take 30 seconds?
Good latency question.
Yeah. Latency is a very real physical limitation of the internet. We all know how long it takes just to load one heavy website sometimes. How is pinging 81 databases actually useful for a business that needs to process thousands of signups a minute? You can't have a customer sitting there staring at a frozen screen for 2 minutes while a system waits for an obscure social media database to respond.
The latency question is usually the very first hurdle technical teams bring up, and it transitions us perfectly into how this sheer volume of data is actually deployed at scale without grinding business operations to a halt.
Because it seems impossible.
Right. If the system were synchronous, meaning it asked database 1, waited for a reply, then asked database 2, and so on, it would absolutely time out. But ArkOwl solves the speed issue through a highly optimized asynchronous architecture, primarily delivered via an API.
So it's parallel processing.
Exactly. The API plugin sits directly inside a company's existing platform. When you type in your email, the system automatically fires all 81 requests concurrently. It does not wait in line.
Oh, wow.
So the total wait time is not the sum of 81 requests. It's simply the time of the single slowest response, which is usually capped at fractions of a second.
Okay, but what if one database is just broken that day?
Good question. If one specific open source database happens to be down or lagging, it doesn't crash the whole query. The API simply compiles the successful returns. It instantly hands the aggregated data back to the client.
Got it.
Furthermore, for situations where a company needs to review a massive historical backlog, they utilize a batch query system, asynchronously processing hundreds or thousands of addresses simultaneously.
You know, Rob Dayline, the CEO, made a really interesting point recently about the human impact of this asynchronous speed. He noted that gathering this exact same context manually used to take him about 3 minutes per email back when he was an analyst.
3 minutes is a long time in that world.
It is, and now that entire process is reduced to less than a second.
Going from 3 minutes of manual digging down to fractions of a second is a profound shift in operational capability. We constantly talk about technology replacing jobs, but this is a clear instance of technology acting as a massive lever for human capability.
Right, it empowers the analyst.
Exactly. Mike Greeling, the lead developer, actually noted that the goal is essentially building the underlying engine so that hundreds of other analysts can do their jobs with unprecedented efficiency. Saving 2 minutes and 59 seconds per query compounds dramatically when you're reviewing thousands of accounts.
So what does this all mean?
Right.
I mean, for the person actually staring at the screen, it's the difference between walking into a massive multi-story national archive, manually searching the index, finding the floor, locating the shelf, and pulling a specific book.
Versus having it handed to you.
Exactly. Versus standing at your desk and having 81 highly trained archivists instantly sprint into different rooms and simultaneously drop the exact highlighted pages into your hands the moment you ask a single question.
That's a great analogy.
The analyst still has to read the pages and make the final call, but all of the heavy lifting of gathering the context is entirely eliminated.
The platform is functioning as the ultimate retrieval mechanism.
Mm.
But that analogy brings us to perhaps the most critical vulnerability in this entire landscape.
The data itself.
Precisely. If you have an architectural system that is incredibly fast and capable of pulling deeply personal digital footprints from dozens of sources in under a second, how on earth does a company handle all of that aggregated data safely without becoming a massive liability?
Data breaches are the modern digital plague. The more intelligence you aggregate into one central location, the bigger the target on your back becomes for hackers.
Right.
And this is where the architecture reveals a fascinating philosophical divergence. ArkOwl explicitly builds their platform with a strict policy of utilizing absolutely no black box algorithms or mathematical suggestions.
Which is a highly deliberate, almost contrarian stance to take in today's tech landscape.
It really is.
I mean, the industry trend is entirely focused on artificial intelligence making autonomous decisions.
It is entirely contrarian, and frankly, I have to question the utility of this choice. I hear the no black box pitch, but let's be realistic about cognitive overload. If a human analyst gets hit with a wall of raw data from 81 different sources every single time a user account is flagged, that's incredibly overwhelming. Isn't a simple mathematically generated risk score like an algorithm just spitting out a 99% probability of fraud warning, isn't that absolutely necessary just to triage that sheer volume of information?
It's a completely valid concern regarding cognitive load, absolutely. But if we connect this to the bigger picture of how enterprise risk management actually works, a black box AI is often more of a liability than a solution.
How so?
Well, the tech industry has been obsessed with artificial intelligence making the final call, but ArkOwl is operating on a philosophy of pure accuracy. A black box algorithm gives you a neat little score, but it completely hides the logic. It obscures the why.
So it's the difference between a doctor handing you a prescription in absolute silence versus putting your X-ray up on the light board and showing you exactly where the fracture is.
Yes, perfect analogy.
One demands your blind trust, the other allows for informed consent and understanding.
That's exactly it. If an algorithm secretly decides a legitimate user's email looks suspicious and autonomously blocks them from making a major purchase, the company has generated a false positive. They've ruined a customer relationship, and they have absolutely no way to explain why it happened because the math is hidden.
That makes total sense.
ArkOwl's argument is that mathematical suggestions inevitably lead to both false positives, blocking good customers, and false negatives, letting bad actors slip through because the algorithm was trained on biased data.
So by providing only the raw, objective data, the X-ray, so to speak, they force the client to see the actual mechanics of the decision. They turn the lights on.
Exactly.
They show you that this email is 2 days old, has no known aliases, and was registered on a high-risk domain. The human analyst, or the client's own internal transparent rule set, makes a final call.
They're providing pure intelligence, not the final verdict. And this commitment to transparency feeds directly into their framework for absolute data security. The underlying mechanism of many massive data providers is a reciprocal pooling model. They often depend on continuously storing and sharing data extracted from their clients to protect and power their own product. You feed your customer data into their machine, They feed everyone else's data back to you.
But ArkOwl firmly rejects that pooling model. Their architecture is built on the premise that the only way to keep customer data absolutely private is to literally not keep any of it in the first place.
Yes.
They do not store or share the valuable customer data that passes through their API.
And by refusing to hoard the intelligence they gather, they completely eliminate the risk of that data being compromised in a breach on their own servers. But they go significantly further than just not storing the final reports.
They use a very specific architectural process for anonymity.
Right. All data requests that a client makes are anonymized and routed entirely through ArkOwl servers.
Let's use an analogy here to explain that. It's like a blind drop in traditional espionage.
I like this.
Let's say I'm a major financial institution, and I want to know if a specific email address is registered on a global social media platform. If my company's servers ping that social media site directly thousands of times a day, we leave a massive, glaring trail indicating exactly who we are investigating.
And that completely compromises your operational security while also totally violating the privacy of the user you are investigating.
Right, so instead, we hire a courier. ArkOwl is the courier. The social media platform only ever sees the courier knocking on the door to ask the question. They have absolutely zero idea that the courier is ultimately bringing that answer back to my financial institution.
ArkOwl acts as a cryptographic middleman. The individual data providers remain entirely blind to who is actually running the verification check. The end user's privacy is insulated, the client's operational security is maintained, and the raw data itself is secured with military-grade 256-bit encryption while in transit.
And because they operate with a strict zero-log policy for sensitive data, the moment the API delivers the intelligence to the client, ArkOwl burns the record of the request.
They keep nothing.
The data passes through their infrastructure like light passing through a window. It illuminates the room, but it leaves absolutely no residue behind on the glass.
It requires immense technical rigor to instantly process, aggregate, and securely route that massive volume of decentralized information and then immediately let it all go. It's an incredibly disciplined approach to data architecture.
So we have this deeply complex, incredibly fast, completely anonymized intelligence engine. But when you step back and look at the practical reality of how a system like this is deployed, it really redefines how we think about the modern internet economy.
It really does.
We always use the phrase trust but verify. But an asynchronous, real-time architecture like this actually flips that concept on its head. It allows businesses to verify invisibly so they can trust instantly.
Without that invisible instant verification, the friction of commerce would grind the digital world to a halt. I mean, if every legitimate user had to manually prove their identity with physical documents just to open an account or make a purchase, the internet as we know it would just cease to function.
And amidst all of this talk of cryptographic middlemen, asynchronous API calls, and military-grade encryption, there is this incredibly grounding detail in their documentation.
Oh, about the pricing and the origins.
Yeah, well, first, the business model itself is super accessible. There are no limits on users per paid account, meaning a whole team of analysts can use it without arbitrary paywall.
And they have very flexible payment options. Businesses can sign up for a monthly subscription or pre-purchase queries and essentially pay as they go. They accept credit cards, checks, ACH.
Paying for the data you use really aligns with the efficiency goals we talked about earlier.
It does. It's very practical.
But the detail I really loved, the copyright line at the bottom of the source material, proudly states that the platform is made with love in Minneapolis, Minnesota.
That's a great touch.
I think that human touch is so important when discussing tools of this magnitude. It reminds us that behind the massive data aggregations and the zero-log policies, there are real humans building tools to solve deeply human problems regarding trust and safety.
It absolutely humanizes the technology.
Yeah.
It emphasizes that we're moving toward a reality where an email address is no longer just a simple communication channel. It is a highly complex key that unlocks a vast, decentralized ledger of your digital life.
Here's where it gets really interesting. When you synthesize all of these architectural decisions together, you realize that ArkOwl isn't just a software tool. It represents a very specific, uncompromising philosophical approach to digital identity.
Right.
They are arguing fundamentally that enterprise security should never rely on secret math, and it should absolutely never rely on hoarding massive, vulnerable troves of centralized data.
Exactly.
Their approach is built entirely on fast, raw, real-time data delivery, empowering the human analyst with the objective truth in less than a second, and then wiping the slate clean.
And bringing it directly back to you, the listener. Whether you are a security analyst on the front lines fighting daily fraud, or simply a consumer typing your information into a checkout page, understanding these mechanisms is vital.
For sure.
Knowing how disparate systems instantly communicate to verify an alias, or how the age of an inbox dictates your level of trustworthiness, it unveils the hidden architecture of the internet. We interact with and rely on that invisible architecture every single day.
It really makes you look at that little seemingly passive sign-up box in a completely different light.
It completely reframes the entire digital experience. And this raises an important question, something for you to mull over long after this deep dive concludes.
Yeah.
We have just explored how an email address alone can instantly, legally, and automatically reveal dozens of interconnected data points about your history across open sources, historical data breaches, and service providers.
So much data.
So at what point does our email address permanently cease being just a mere inbox for our newsletters and receipts, and essentially become an inescapable, unerasable digital fingerprint?